In the previous video, we used pork supply data to create a regression where pork production in the current period of these months listed from January 1975 to December of 2018 is the outcome variable, and then our explanatory X variables are last year's pork production, pork price, real corn price. These are all last year. Corn price lagged 4 periods, these are quarters. So these are all lagged 1 year. Again, production price, corn price, and soybean price. So how do we interpret the summary output that we've just created? The first thing that we want to look at is our R squared statistic. Our R squared statistic tells us what percentage of the overall variation in our outcome, what percentage of the overall variation in pork production this month is explained by pork production last year, pork price last year, corn price last year, and soybean price last year. In this case, we see that 91% of the variation is explained. Depending on the model, R squared can be high or low. In this case, what this is saying is that the variables that we have in our model explain a lot of the variation in pork production. In other models, R squared might be lower, and that might be okay. We tend to use R squared to compare between prospective models. For instance, we might add some variables to the model and see how that changed the percentage of variation in pork production explained. The adjusted R squared then adjusts for the number of observations we used and the number of explanatory variables we have here in our X matrix. In this case, we have 4 of them. Moving on, our analysis of a variance gives us, first of all, the joint significance test, F. The joint significance test tells us, are our explanatory variables together good at explaining variance in our outcome? In this case, we have a very high F and a very low significance. That's 7.64 times 10 to the negative 272. So that's a very small number. We would say that these are jointly significant in predicting pork production in the current period. We can also interpret our coefficients individually. Usually we don't do too much with interpreting the intercept, but we do usually include it in the model. But here, this is saying that if pork production changes by 1, I don't know if these are pounds or tons, these must be tons or something like that. If pork production changes by 1 unit, then pork production in the current period, if lagged pork production changes by 1, then current pork production will change by 0.94 on average. This is statistically significant. The p-value is very low here, and so we can tell for sure that this coefficient is statistically different than 0. All right, so we can go on and do our interpretations. For example, if the pork price changes by 1 unit, it looks like dollars in this case. If pork price changes by $1, then pork production in the current period changes by 1.47 on average, and so on. So that's how we interpret our coefficients. Next, we want to use the coefficients from this model in order to create predictions. In previous classes, we've used the coefficients from models like this to calculate elasticities. Now we're going to use the coefficients from the model to predict values in each period. So let's go ahead and produce another column of data here, which is predicted. And we know, given our linear equation, that our predicted value for any given period should be the intercept of our model, alpha it's usually written as, plus, need our equal sign, try this again, equals our intercept plus our coefficient on last year's pork production times what the pork production was in that period, plus coefficient on pork price times our pork price value, plus our corn price coefficient times what our corn price was in that period. Finally, adding soybean coefficient times what our soybean price was in that period. Now, just for demonstrative purposes, let's go ahead and press enter here. We get a predicted production, which is actually not too far different from the actual production. Later, we'll create a graph and see how close we got. But if we were to autofill this down, we can see that we start getting some values which don't make any sense. So what happened? Well, if you've used Excel enough, you know, it probably predicted this, that we needed to use absolute references for our coefficients over here so that they don't change as we autofill. So in other words, all of our coefficients from our I categories, we need to turn into absolute references by adding our dollar signs. Let's do that now. Okay. So we can see that doing that doesn't change our predicted value in the first period, but then when we autofill down, now our coefficients aren't changing, scrolling down as we go, and so we get the correct values here in our predicted category. All right, next, we might be interested in visualizing how close our predictions get to the actual observed pork production. So let's go ahead and first highlight our date category and our outcome variable, pork production. And then let's hold down on Windows, it's Control. On Mac, it would be the equivalent of Control. But if we hold that down, we can also select our predicted category. Right? So we've got our predicted category selected, and then we've got also our date and pork production variables selected. Now we want to insert a line graph. This is actual pork production versus predicted. Okay, and so that it's not right on top of our data, let's cut that and then just copy it back over here. Right, so there we go. Now we can see that our model does a reasonably good job of predicting, based on data, what the pork production in that period would be on average based on the observations of all of our explanatory variables. Right, so doing something like this, and again, remember to include that date variable in there so that we get a nice clean date here on the x-axis. Otherwise, it'll just give you like a number of the observation 1 through 533 or whatever it was. But doing this is a good skill to develop. You know, there's a lot of companies who will employ at the entry level just to do things like this. In some cases, you'll need to go out and get data for them, but in many cases, not. In many cases, it's sales data, which they already have. And so they're looking for analysts who are able to run simple regression models, create predictions, and then use those predictions to see how their model is performing. Right, so I'll stop this video here, and then I'll post one final short video on using our predicted values from our model to forecast future values.